Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, 2016 question 7. Let's have a look at this one. And it looks like a compound interest type question. Paul has €8,000 that he wants to invest for a maximum of 3 years. His local bank is offering him two options, option 1 and option 2 as shown in the table below. So option 1, 2% interest in year 1, 3% in year 2, 5% in year 3. Money can be taken out at the end of year 1 or year 2 without penalty. Okay, option 2, 3.7% compound interest per year for 3 years. Okay, so that means you get 3.7% every year. Money may not be taken out until the end of year 3. Okay, A, find the value of the investment at the end of 3 years if Paul chooses option 1 and does not take any money out. Okay, so for compound interest, we're at page 30 in the log tables. We are using this formula here. So let's copy that over to here. Okay, so let me just go through it. So this is the financial maths page in your log tables, and it's the compound interest formula. Okay, and normally the question will say compound interest somewhere. Okay, so when I see that, I think of this formula. P is the principal. That's a business term, and it normally means the amount you're starting off with or the amount you're investing. And then up here you see T is the time in years, and I is the interest rate or the annual rate of interest, depreciation or growth. This is important, expressed as a decimal or a fraction. Okay, so you can't put in 8% or 8, for example, for I. You must put it in as 8 over 100 as a fraction or 0.08 as a decimal. Okay, so keep that formula, keep that page in mind anytime you see any of those financial maths questions. So a couple of things about this formula. T is the time in years, okay? So for option 1, this is how you would not do it. And you see that you're investing it for 3 years, okay? So in theory, you're to the power of 3. Now, you cannot use this formula in this case. Why? Because that interest rate that's there keeps changing. Do you see it's 2% in 1 year, 3% in year 2, 5% in year 3. So which one of those interest rates would you put in here? Well, it changes over the 3 years. So the formula doesn't really work for this particular question. Well, not directly. Okay, so what do we do in this case? Well, I suppose the older way of doing it is, so this would be year 1. I'm starting off with 8,000 and I get 2% of it. So divide by 100 and multiply by 2 so that I'm getting 2% of it. So 8,000 divided by 100 multiplied by 2. So you get €160. So that's the interest that you will earn. You add it on to the 8,000, which is what you started the year with, and you get 8,160. Okay, so in year 2, you start off with 8,160 because you've already earned €160 interest. And again, I need to get 3% of it this time because that's what this deal gives me, 3% in year 2. So 8,160 on my calculator divided by 100. I'd multiply by 3 in this case, and I'm getting 244.80. And I add it on to what I started the year with, so the 8,160. So 8,404.80. So I start year 3 then with €8,404.80. I divide it by 100 and multiply by 5. and the interest I'm earning this time round is €420.24. I add it on to what I started the year with, 8404.80, and I get 882504. Okay, so that's your answer. That is the value of the investment at the end of 3 years. Okay, so you can see a fair old bit of work for it. They did give 10 marks for it, so there's a fair old bit of work. Okay, so that's one way of doing the question. And it's a lovely way of doing the question because you can see exactly what's happening. You can see the percentage changing per year. You can see the amount going up all along, and you can see what's happening. So it is a great way of doing these type of questions. Okay, but is there any way I could use that formula? Because let's think there's some students out there who would prefer that formula. Okay, well, yes, but you just have to do it 1 year at a time. So in other words, at the end of year 1, my final amount would be 8,000 times 1 plus my interest rate in year 1 is 2%. Now as a decimal, you divide that 2 by 100 and you get 0.02, and it's just for 1 year. Okay, so put that into your calculator. And you'll see you get 8160. Obviously the same amount you got at the end of year 1 this way. Okay, year 2, how much is my final amount? Well, my principal, or what I'm starting the year with this time, is 8160. I have an interest rate of 3% this time. Okay, now this is where it's easy to make a mistake. You don't put 2 here because it's year 2. You still put 1 there because you're only gathering interest on it for 1 year. Okay, year 1 is over. It has already got interest for year 1. So how long is it getting interest or accruing interest at 3%? Well, just for 1 year, for that second year. So think about you in school, it's for your second year of school, for example. Okay, so that's a mistake that's very easy to make. So if you think you won't make that mistake, then this is another option for how to do this question. And I don't know why I worked it out because I have the answer down the bottom, but 8404.80. Okay, for year 3 then, your final amount is 8404.80 times 1 plus 0.05, again to the power of 1 because we're only leaving it there for 1 year. And I get 882504, well, I presume I do, okay? Which is what we got the last time round. So 2 ways of doing it, totally up to you. You're going to get full marks no matter which way you do it. It's just personal preference as to which way makes more sense to you. Right, let's have a look at part B, because part B was also worth 10 marks. Find the value of the investment at the end of 3 years if Paul chooses option 2. Okay, and option 2 is 3.7% compound interest per year for 3 years. Okay, the long way of doing this would be year 1, you would do 8,000 divided by 100, multiply by 3.7%, get your interest, add it on to 8,000 and work out the total amount. And then do the same for year 2 and do the same for year 3. So in other words, exactly what we did up here, except the interest amount stays the same. Okay, now for this one though, this is where that formula comes out to its own. So F is equal to P times 1 plus I to the power of T. My principal amount, I'm starting with 8,000. My interest rate is 3.7. Don't be afraid to divide that by 100 on the calculator to help you convert it to a decimal if you need to. And it's to the power of 3. So because the interest rate stays the same for all 3 years, you get to do this all 3 years, all in one go. So this is when this formula is super. to the power of 3. And to get that power of 3 in, you can always use that button there. It's just under, it's in the center, and it'll allow you put it in. And if I it equals, I'm getting 8921.26 euros, always round to 2 decimal place. Okay, so then you might ask yourself, well, which one is better? Well, B looks better because you've earned more money. Okay, part C, give one issue other than the rate of interest earned that Paul might take into account when deciding between option 1 and 2. Okay, other than the rate of interest, okay, which implies that it's not this box or not this box, it must be this. Okay, so the other issue, money can be taken out at the end of year 1, year 2 without penalty. Here, in this one, money may not be taken out until the end of year 3. Okay, so the issue then clearly is money may not be taken out until the end of year 3 if going with option 2. Okay, and keep writing because you'll then hit off something, you'll hit off whatever they're looking for. With option 1, you can take the money out at any stage. Okay, or something to that effect, whatever makes sense in your head. D. Paul would like his investment of 8,000 to amount to 8,000. Sorry, Paul would like his investment of 8,000 to amount to 9,000 after 3 years. What annual rate of compound interest would be required for this to happen? Give your answer as a percentage. Right. Now, this is a particularly hard case of the compound interest formula, which was this one. I'll just write it out again. Okay, so the 8,000 is what we start with. Okay, so that's your P. You want it to amount to 9,000. That's your F. Your T is 3 years. And what annual rate of compound interest? So you're solving this for I. So this is actually the hardest question they can ask on this particular formula to solve for the interest rate. Okay, but at a minimum, try and write out the formula with all of your information. Something like that. Okay. So then you solve it for I. Okay, so you strip away everything from this side until you get I, the interest rate on its own. So the easiest thing to get rid of first is the 8,000. The 8,000 is attached to this through multiplication. That's multiplied by that. Okay, so to bring it over the other side, you divide by 8,000 to cancel it, and what you do to one side, you must do to the other. Okay, so 9,000 over 8,000 is 9 over 8, and that's equal to 1 plus I to the power of 3. Okay, so that's where we're at. Okay, if I said something to you like 16 was equal to x squared, how would you get rid of this power? Well, you do the opposite of it, which is square root. Okay, now we have to the power of 3 here. So it's a similar job, it's just not square root, it's 3 root. Okay, so to get rid of that power, we go 3 root 9 over 8. Okay, so why did I do this? Because on the right hand side now that 3, that power of 3 cancels with 3 root. Okay, so can you see, I'm just going to rub this bit out here. Can you see that you're now left with on the right 1 plus I And then what I do to one side, which is the 3 root, I have to do to the other. So into your calculator, put 3 root 9 over 8. And the 3 root button, you have to hit shift for this one. It's right behind the square root button. So 3 root 9 over 8. And I am getting 1.04 and a load of zeros for that. Okay, I need to solve for I, so subtract 1 from each side. So I'm getting 0.04 then being equal to I. Now remember what this formula does, it gives you the interest rate as a decimal. We normally give interest rates as percentages, so you need to multiply this by 100. So I'm just going to come over here to the left a little bit. I hope I'm not confusing you. So I'm going to go 0.04 multiplied by 100. So I get 4% is the interest rate. Okay, so that's how you do that one. And it's the same steps. It's the same question that comes up all the time. Okay, the P will change, the values will change, the P, the F, and the T will change, but the steps are the same. So try and get used of 3 root being the opposite of to the power of 3. If that was to the power of 5, then I would have 5 root here. Okay. Okay, with squares, if I go back to my 16 being equal to x squared, when I do a square root, there's actually a silent 2 there. We just don't write it in, and that square cancels with those 2. Okay, so that's why the cubed one cancels with that. Okay, so that now question was difficult enough. And then part E. Another bank offers to invest his 8,000 in a special fund. The bank has found that, in the short term, the amount of money in the fund follows the formula V equals, where V is the value of the fund in euro and T is the time in months. Since the 8,000 was invested, find the value of the money in the fund after 12 months. Okay, that doesn't read too bad. V is the value of the fund. Okay, so I'm going to solve for V, and T is 12. Okay, so this is a perfect example. Even if you couldn't do this part D, don't assume then that you can't do part E. So watch out for that. You may be able to do further parts. Okay, so this is just V, the value of the fund, is equal to 8,000 plus 36. T is time in months, minus 1.2 T squared. And I put that into the formula, or sorry, into the calculator. 8,000 plus 36 bracket 12 minus 1.2 bracket 12 squared. And I got phi being equal to 8259.2 or 0.20 because it's money. It's the value of the fund given that formula. So that was nice and easy. Same amount of marks for that part as there was for this one here. Okay, you just never know. Mary invests 8,000 for 1 year at % per annum. After 1 year, her investment is worth the same amount as the answer to part E1 above. Find the value of or correct to 2 decimal places. Okay, Mary invests 8,000 for 1 year at % per annum. After 1 year, her investment is worth the same amount. Okay, so a couple of ways you can do this. Again, either way, our principal amount is 8,000. After 1 year, the final amount is worth the same amount as above, so 8259. I have 1 year and I need to find my interest rate. Okay, so I could of course do P is not F equals P times 1 plus I to the power of T. So 8 8,259.20 equals 8,000 times 1 plus I to the power of 1. Divide both sides by 8,000, just like we did on the last one. 8,259.20 over 8,000. And I'm getting 1.0324 is equal to 1 plus I. Subtract 1 from both sides to get rid of that 1 on the right. So I get minus 1. 0.0324 is equal to I. Multiply him by 100 to change him to a percentage. And therefore I get I equal to 3.24%. Okay, so that's a way of doing it, perfectly the same as D. Okay, if I could show you another way of doing it, not quite so formal, just in case you see it a little bit different. You could, of course, go, well, what's your interest? So interest in money. So what did you end the year with? Minus what did you start the year with? Because isn't the difference between them your interest? So that's €259.20 in money. So put the difference over the original. I don't know if you've heard me saying that formula. I multiply it by 100 over 1 to change it to a percentage, or just multiply by 100. That will also change the interest in money to interest as a percentage of the original. Multiply by 100 and 3.24%. So that's another way of doing it. Where do you end up using this type of formula a bit? Well, if you're asked for percentage profit, then you'd put profit over the cost, or percentage loss, it's the same thing, loss over the cost. So anytime you're asked for percentage, it's difference over the true value or the original value. So either of those ways will give you the answer to part 2. And that was the end of that question. So quite a long question. It was, I think, 55 marks long, as is typical for one of the long questions at the end of the paper.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in electronics and self-driving technologies, and from there to the Masters.
Check out the link below for more information.